Okay, so how can we understand the interactions that are produced by factorial designs? Well, an interaction is when the effects of one independent variable depend on the specific level of the other independent variable. Okay, so let's look at this graphic. This is along the x-axis, we're seeing the males versus the females, so that's one independent variable that has two levels. So sex can serve as an independent variable. This is a between subjects variable, of course, because you've got different people in the male condition than you have in the female condition. Okay, so we've got sex along the x-axis. The y-axis is always the dependent variable. So this is the percent of emergency department visits that were attributable to different kinds of overdoses. All of them were involving energy drinks. That is a given. And then what they were interested in is energy drinks mixed with what? So in the dark blue, we've got alcohol being mixed with energy drinks. In the blue, light blue, we've got illicit drugs being combined with energy drinks, and in the gray, we've got pharmaceutical combinations, so some kind of prescription drug. Okay, so you can tell just by looking at the pattern of the bars that there's an interaction between sex and combination, mixture. I don't know what we call this independent variable. Combination, I guess, would be the right term. So we've got an interaction between sex and combination, and the way that we can tell that is by looking at the bars. You don't even have to look at the numbers. You don't even have to look at these percentages. You can just look at the bars. So we've got blue bar, dark blue bar versus light blue bar, dark blue bar versus light blue bar. Okay, they're looking reasonably symmetrical, and if we actually look at the numbers, 20 versus 12, 10 versus 5, I guess if this had been a 6, it would have been a perfect, match, right? Where each of them is half as big as what we saw for the males. So the pattern of the blues is looking reasonably similar. Where we're seeing a difference between males and females is in this gray bar, the pharmaceutical combinations. You'll notice that the pharmaceutical combinations is slightly bigger than the blue bar for the males, but it's way bigger than the blue bar for the females. So it's 3% higher for the boys, for the men. It's more than 3 times as big for the women. So you can see that there's an interaction between sex and then the combination that brought you to the ER. So percent of emergency room visits is a function of which sex you are and what substances you combined with your energy drinks. Males seem to be almost equally likely to do alcohol and pharmaceutical combinations, whereas females are much more likely to combine their energy drink with pharmaceuticals. So what I was trying to describe there is how we can see a significant interaction by just assessing the bars in the graph and seeing if they look different based on which condition you're in. Hopefully my verbal description made it clear what you're looking for, that you're looking for a lack of symmetry between the groups, and that really reveals an interaction is present. If the interaction hadn't been significant, we would have had bars that, I use the phrase here, equal height. I don't know if that's the right way to describe it, but proportionate, right? So we've got blue 20, blue 10, blue 12, blue 5. Gray 23, this one should have been something like 12 to be proportionate to the pattern that had been seen in the males. That would have been, if you'd seen something like that, if this 35 had been something more like 12 or 13, we would have been able to say, doesn't matter what sex you are, that it seems like the pattern's similar. But instead, what we've got is a significant interaction where pharmaceuticals is way more common for females than it is for males. Okay. Now in class, I like to assign this to groups and have students try and figure out, based on this graph table that I've got here, which is based on the results from what's called a meta-analysis of 20 different studies that were looking at whether males or females became emotional in different situations. What we want to try and figure out from these 20 pieces of data is whether the researchers were able to establish whether women were more equally or less likely to be emotional than men were. So since we don't have groups to get into or anything like that, I'll sort of walk you through it and let you pause me, see if you can figure it out, and then come back and hear what I have to say. Okay, so what you have to do to figure it out is, first off, this first column, it says my little female sign and then a question mark. If the participants in the study were female, then it'll say yes. If they were male, it'll say no. So you can figure out the sex of the participants based on yes is female, no is male. And then were they emotional or not is the next column. If they were emotional in the study, then it says yes. If they were not emotional in the study, then it says no. So that's all I tell my students in class, and I tell them try and figure out however you want, try and figure out whether you think that the researchers concluded whether that women were much more, somewhat more, slightly more, equally, slightly less, somewhat less, much less likely to be emotional than men. Okay, so if you'd like to work that out, go ahead and pause me and then come back. Okay, so hopefully you all did it because it's kind of fun to try and figure it out. It takes a second. Let me go to my, usually what I do is have the groups tell me what they did and then we do it on the board, but we don't have a board, do we? So what I'm going to do is make this smaller so we can see it. And then let's get rid of that so we can see it. Okay, and then I'm going to go over here to my handy dandy Excel spreadsheet and make a table. Okay, so hopefully this is what you did. First, hopefully you kind of made a little table and you put like sex, and you have female, and you have male, and then hopefully you did the other independent variable, should have been emotionality. Let's go emotional, and then we'll go yes or no. Okay. Now, a lot of our stereotypes tell us that the female should have been more emotional, so we may already have a bias that can interfere with our ability to actually process this information efficiently. But let me show you how you should process it to make it make more sense. Okay, so we've got how many studies that included women? Well, let's go ahead and count the men instead. 1, 2, 3, 4 studies that included males. So I'm just going to go down here in the bottom here and go 4 studies were male. And then there were a total of 20 studies, so this has to be 16, right? Then we look at whether they were emotional or not. And I'm going to go ahead and count up how many studies had people who were not emotional. 1, 2, 3, 4, 5 studies that were not emotional. That means the other 15 they were. Okay. So now we can go back and count up how many yeses there are. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 studies where they were yes female, yes emotional. And then we have for the no yeses, we've got 1, 2, 3. Okay, we can kind of leave the rest of these blank because it doesn't really matter, right? Because what we're looking for is were the women more, less, equally likely to be emotional than the men. 12 out of 16 studies the women were emotional. 3 out of 4 studies, the men were emotional. I don't know about your math, but I'm coming out to the conclusion that these are both 3/4 of the time the participants were emotional, regardless of their sex. This is a different kind of two-factor design where we've got their sex and then emotionality as the other variable. This is another way to sort of find out whether two factors are important in an outcome, right? And we have to look at both things in order to draw a correct conclusion. If we had only counted up how often females were emotional, it might have given us an incorrect impression, because 12 studies where they were emotional sounds like a lot, right? But then when you find out that, well, first off, they didn't do very many studies that had male participants, and in those that they did, the males tended to be emotional at the same rate that women tend to be emotional. You start to realize what the pattern really is. That's the important thing on factorial designs. It gives us more information to draw better conclusions. Okay, so let's go ahead and take a break here, and we'll come back and talk about, well, why are we so lured by the single causation explanation?